on stage now. All right, yeah, it's good. I think I am not taking every space, and I hope you can see me. Can see the boards. I don't know. I'm just the only one here, so I don't know whether I'm covering the boards or I should stand this way so I can easily see the board. But all right, today is our day one of our 30 days marathon, and 30 days expose. See, three classes. We want to expose everything when it comes to JAMB in 2026. And today we are going to start with the very first topic, which is atomic structure. Now, atomic structure is very important in biology, in chemistry, sorry. You cannot do chemistry without talking about atoms. Because atom is a basic unit. You understand? Atom is a basic unit of matter, which chemistry is built upon. So I want to discuss everything about atomic structure. Now, this is atom and structure. So first of all, talk about what atom is all about. Then we decide to talk about the structure of atom. Back in the olden days, before science evolved, we believe that an atom is what? An indivisible particle of what? An element. It was always believed that an atom is a what? Indivisible particle. Atom is what? Indivisible particle of what? An element. An atom is the indivisible particle of elements. That is what we used to believe atoms to be. We believe that atom is what? Indivisible. Right? Now, we have been built with this knowledge over time. But before then, you have to note that we first of all have atoms. From atoms, we have molecules. And from molecules, we have matter. So we have atoms, molecules, and matter. And we always believe that atoms are what? Indivisible. Not until some certain scientists came out and said, no, you cannot say atom is what? Indivisible. Atom is divisible. You understand? They say atom is what? Divisible. That this atom that we think is indivisible, let's assume this is atom, and we believe this atom is what? Indivisible. They believe that this atom, despite the fact that it's indivisible, it is still made up of particles, subparticles. And that was what brought about the discovery of subparticles of atoms in chemistry. So we say discovery of subatomic particles, say subatomic particles. We believe that an atom is made up of, number one, it is made up of proton. Number two, it is made up of neutron. And number three, it is made up of electron. This is what we believe atom is made up of. It's made up of proton, the neutron, and the electron. Now, each of these was discovered by certain scientists, different scientists, in the course of their experiments. The proton was discovered by scientists, the neutron was discovered by a scientist, and likewise the electron. And each of these also have their what? Charges. So we'll start with the what? The proton. Now the proton is believed to be what? Positively what? Charged. The proton is believed to be positively what? Charged. And the proton was discovered by a scientist known as what? Ernest Rutherford. So it's a proton positively what? Charged. And discovered by what? By Ernest Rutherford. We believe that the proton was discovered by Ernest Rutherford. That was a man that discovered what? Proton. We move on to talk about the neutron. The neutron is gotten from the neutron is gotten from the neutral. That means it does not have any what? Charge. It is what? Neutral. And it was discovered by a scientist known as James Chadwick. James Chadwick. This was the name of the scientist that discovered what? Neutron. And we say this what? Neutral. Then we talk about the electron was discovered by a scientist, or first of all, the electron is what? Negatively what? Charged. So you say negatively charged. the electron is negatively what? Charged. And it was discovered by a scientist known as what? J.J. Thomson. This was a scientist that discovered the concept of what do you call it? The electron. Welcome to my live stream section. Yes, sure. Welcome to my live stream section. Welcome to my live stream section. Divine for Life, RO6P. Can you do electrolysis? Divine, you're welcome to my live stream section. Please, Divine, don't forget to subscribe to my YouTube channel and also share this lesson for your friends. Okay, like I said, we are having an expository class. We are going to have this class, a marathon class, from 2nd of March till the last day in the month of March, where we are going to have a little break. Now, what we are going to do, we are going to cover up those topics in chemistry and also in biology. So we are starting with the foundation. We don't want to just go to electrolysis. We are beginning with the foundation. So the concept of electrolysis, organic chemistry, we are going to cover them all. So organic chemistry, if you're having problem with organic chemistry, electrolysis, the gas laws, we are all going to cover them in the course of this class. That is for chemistry. Then for biology, we are starting with the classification of living things, which is the basic, up to variation, evolution, genetics, hereditary, all those ones we are also going to cover it. So the best way is just to subscribe so that tomorrow again we are going to go live Wednesday, Thursday, Friday till the very last day in the month of March. So that is what we are doing. So today we are focusing on subatomic particles. We are going to introduce the class first. Then we solve past questions based on this. These past questions are strictly JAMB past questions. So these are subatomic particles. And like I said, these are the proton, the neutron, and the electron. Now, look at the representation of my atom. Right? That is the representation of my atom. And now, look at what happened. This is atom. The question there is, where is the proton, the neutron, and the electron found? If you say an atom, let's assume this is what atom. If you say this atom is divisible, right? So if I divide it, where can I find the proton? Where can I find the neutron? And where can I find the electron? So we say this is our atom, and we say the proton, which is the positively charged, and the neutron is found inside of the atom. They are found inside of the atom. So let me use my blue pen to represent my blue marker. So say they are found inside of the atom. This is the proton, and the neutron. They are found inside of the atom. Now, the proton and the neutron being found inside of the atom, collectively, they are known as nucleus. So we say collectively, they are known as nucleus. So the proton and the neutron is what is called nucleus. So when you hear nucleus, what should come to your mind is proton and neutron. Then the electron is found here. The electron is found on the body, the outside of the atom, right? So this is the electron. So we say this is the electron, and the inside is the proton and the neutron, which is known as the nucleus, right? So this is the position, or this is where we can find these subatomic particles, right? So that is just how it is for this particular discovery. Now we still continue to talk about the concept of ions. When a lot of people hear ions simply means charges. So ions simply means charges. Ion simply means charges. Now, this charge can either be positive or it can either be negative. Right? So it can either be positive or negative. Are we together? And when it is positive, so we have positive and negative. When it is positive, it becomes anions. And when it is negative, it becomes cations. Right. So please don't forget this. We have Anions are what? Cations. So these are what? This is what is known as what? Ions. Also, please take note. I hope you are following. In case there's any way you don't understand, please let me know. We are okay. Divine Favor says our class is just time of 1 hour 30 minutes. That is how we structure our classes to be. Our class is structured to be for 1 hour 30 minutes, depending on how we are able to cover up the questions, right? So we are just trying to treat this, then we cover up the past questions just for 1 hour 30 minutes. Please subscribe, and also share my my videos to your friends, right? Thank you so much. All right, so let's talk about the concept of electronic configuration. Let's talk about the concept of electronic configuration. So you hear this term, electronic configuration. Right? Now, electronic configuration is the arrangement of elements. So please, if you are writing, let me know. Electronic configuration is the arrangement of elements into their what? Orbit. The arrangement of what? Elements into their what? Orbit, based on their what? Relative atomic number. So electronic configuration is done based on the concept of what? Atomic number. Electronic configuration is done based on the concept of what? Atomic number. The atomic number of hydrogen is 1. The atomic number of helium is 2. The atomic number of calcium is 20. The atomic number of chlorine is what? 17. So when you say hydrogen, helium, lithium, beryllium, boron, carbon, right? When you are following it like that, that sequence, where you say number 1 is hydrogen, that is what is known as what? The atomic number. Now, atomic number is the number of what? Protons. The atomic number is a number of protons. So atomic number equals to number of protons. The atomic number equals to number of protons. Please take note of this, because when you start checking the past questions, you are going to see things relating to this. You are going to see questions based on this. That's why it just came to my head, and I have to bring it out here. So I say electronic configuration is a filling of what? Electrons, or the arrangement of what? Electrons based on their relative atomic what? Number in the what? Orbitals. So let's say we have chlorine, right? We have chlorine. Let's use chlorine. Chlorine is 17. Chlorine is what? 17. Now, from here, I'm going to talk about something, but it's gradually, because I have to end it, the teaching which I believe you have done. Then we go to the past questions and see how we can answer those past questions. As we answer the past questions, we learn. After the past questions, we learn. So now let's use chlorine. So we have what is known as atomic orbital, right? We want to give the electronic configuration of what? Chlorine. Now, we have what is known as what? The atomic what? Orbitals. And we know that the innermost orbital, right? The innermost orbital must contain a maximum of 2 electrons. The innermost orbital must contain a maximum of 2 electrons. And the outermost must contain a maximum of 8 electrons. So we are using chlorine, and I said the arrangement of atoms based on their relative atomic number. The atomic number of chlorine, right, is 17. So we say the innermost now. The innermost is going to contain what? 2. All right, no, let me use. I wish I was with my son. The innermost is going to contain what? A maximum of what? 2. So this is 1, 2, right? And the outermost must contain a maximum of what? 8. So we have 1, 2. All right. So this is what? 10, right? This is 8 plus 2, which is what? 10. We are now left with 7. So we have to 1, 2, 3, 4, 5, 6, 7. Right? Now, so we have what? 10, 2 plus 8, 10 plus 7 is what? 17. Right? So this is the electronic configuration. Please note, because I want to use this thing and explain something. This is the electronic configuration of chlorine. Now, inside of here, Inside here, we have what is known as valence electrons. Valence electron is actually different from electrons, although like valence electron is gotten from electrons, but has a little bit of difference. So you have what's known as valence electrons. Valence electrons is the number of electrons or the electrons that is in the what outermost what shell. The electron in the outermost shell, the number of electrons in the outermost shell, that's what the valence what electron. So the number of electrons in this outermost shell in chlorine is how many? It's 17. Sorry, it's 7. Your 1, 2, 3, 4, 5, 6, what 7. So the valence electron of chlorine, is what 7. The same thing applies to what hydrogen, which is what just 1. Right? And the same thing applies to what other what elements. So when you fill the orbital, let's say you fill the orbital, and peradventure it is just left with 1 electron outside here, right? This electron that is left outside here is not what the valence or electron, and you can say, okay, this element have what 1 valence what electron. So that is the concept of what valence what electron. The electron found in the what outermost what shell, right? So I've talked about atomic number being equal to the number of what protons. So let's see, let me get my phone, because let me get my second phone, because that is where we are going to be getting this JAMB question from. And as we get the question and we see any other thing that we need to talk about, we are going to discuss it, right? All right, so let me get the questions now. Please subscribe to my channel. Please subscribe to my channel. God bless you. Thank you so much. All right, so we are getting the questions now. Okay, let's get into questions. All right, so we have gotten the questions right here. So this is the questions, right? These are the questions we have. I have the questions here with me right now. And the first question here, let me keep this blue marker. The first question we have here says, the atomic number of an element is 16. How many electrons does it have? The atomic number of an element is 16. The atomic number of an element, is what? 16. How many electrons does it have? How many electrons does it have? Please, you can support our live stream classes. With data, airtime. I can also chat me on WhatsApp on 07062462746. My name is Basi Ejogba. Alright, so just chat me on WhatsApp on 07062462746. 07062462746. That is my WhatsApp number. Chat me up on WhatsApp. Now the question says, the atomic number of an element is 16. How many electrons does it have? We have A, 8. We have 8. We have B, 16. We have C, 32. And we have D, 15. The atomic number of an element is what? 16. How many electrons does it have? Now, first of all, atomic number equals to what? Number of what? Protons. Right? The atomic number of element is 6. How many electrons does it what have? Now, this answer is very what? Simple. In a neutral atom, an atom that is what? Neutral. In a neutral atom, proton equals to electron. right? Proton equals to electron. So drop the answer, drop the answer. Let me see. Has anyone dropped the answer? Drop the answer. Just try and drop the answer. The atomic number of element is 16. How many electrons does it have? Right? Let me see. Drop the answer. Following, knowing fully well that I have explained that atomic number equals to what? Number of what? Protons. How many electrons does it have? Okay. Right? Divine says 8. Yes. And another person should try. Then I will give the final answer. Divine has tried. Divine says 8. Now, Divine, try and get this. I want to explain something now. Divine, try and get this. Right? I want you to just look at me what I want to do now on the board. The atomic number of an element is 16. How many electrons does it have? Knowing fully well that in a neutral atom, the number of proton equals to the number of electron. And remember, I said atomic number can also be known as what? Number of what? Protons. I would say the number of proton is 16. And this is in a neutral state. This is in a neutral state. So if the atomic number, which is the number of proton, is 16, what is going to be the number of electrons from the option that we have? Have you seen it? Do you get it? Divine, do you get it? You find out that the answer is what? The answer is what? 16, which is what? B. The answer is 16. So Divine, the answer is what? 16. Because the number of what? Proton, right? The number of proton is the same thing as the what? Atomic number. And this is what? In a neutral what? State. So the proton is 16. The electron is also going to be what? 16, right? So that is just how what it is. So let's get the second question. We have the second question. People should be active so that you'll be answering the questions and we are going to be very fast. Right? So we have the next question. The next question says, an atom has a mass number of 23 and an atomic number of 11. What is the number of neutrons? All right. So let me just write my phone number visible here. In case anybody want to chat me up on WhatsApp. Divine, chat me on WhatsApp. Right. Okay, better. An atom has a mass number. So you have question number 2. An atom has a mass number. Of 23. Has mass number 23. And atomic number 11. Atomic number of what? 11. What is the number of neutrons? What is the number of neutrons? What is the number of what? Neutrons. An atom has a mass number of 23 and atomic number of what? 11. What is the what? The number of what? Neutrons. Right? We have, okay. There's no option. There's no option that was given. Right? So no option here. Can we try? Now, the formula is this. Let me give you the formula, because when I give the formula, let me give you the formula. Please subscribe, and also share my videos to your friends. Share it to your, if you are still in Sunday school, share it to your class group chats. If you are still in Sunday school, share it to your class group chat. If you are attending any JAMB class, share it there. You understand? Then also, you can also be part of my special WhatsApp classes. That one is just 5,000 for you to be part of my special WhatsApp class. You understand? So they have taken likes. So they have taken like. Please, I hope you can see the board, right? They have taken their light, seeing the kind of country we are staying. But let me see how I can get my battery. We can still have this class now. No, let's continue. We can still have this class even without the battery. Well, let me get the battery. Battery. Oh. Okay, people can see it. All right. Let me just see. I want to just get the battery, so just I charge the battery, but I know that the battery is not going to last too. But at least for the meantime, all right. Okay, yes. Although I know it's not going to last too, but okay. Now the formula for this, an atom has a mass number. The formula is this: mass number equals to atomic number, right? Atomic number minus what? Neutron. That is the formula. Mass number equals to what? Atomic number minus what? Neutron. And in this case now, we are being given the atomic number. So in this case, so let's say solution. Let's say this is solution, right? In this case, we are being given the mass number. So we say mass number equals to what? 23, right? Atomic number equals to what? 11. Neutron is unknown, but that is what we are looking for. Using this formula, we substitute the values, right? So say mass number here is 23. So let's substitute the value. We say 23 equals to atomic number is what? 11 minus what? Neutron. Because the neutron, 11 minus what? Neutron. Now, because the neutron is what? Unknown. Now, we have to make the neutron subject of the what? Formula, right? We have to make the neutron subject of the what? Formula. So, what we are going to have is going to be neutron equals to, so the neutron is going to cross, because we are making the neutron subject of the what? Formula. We are going to cross the what? The neutron, this one. Right? So we are going to cross the word neutron. So we are going to have neutron equals to what? 23 minus what? 11. Neutron equals to 23 minus 11 is going to give us 12. And that is the answer. Do you get? That is the word. That is the answer. The answer is what? 12. Using the formula on the board. Mass number equals to atomic number minus what? The neutron. Right? So that is how we solve for this. That is question of these are JAMB questions. So these are JAMB questions. So we are going to follow up like that. All right. We have the next question here. Although this particular question I want to read now. Okay, we have two questions here that does not, so we clean this, right? We have questions here that does not involve solving. So this one we can just, please, I hope you have copied it. Copy the formula, which is when you have the formula, then you have the values listed out. Solving it is not going to be what? An issue. This is basic what? Simple equation in mathematics, right? So you just try to cross, get the answer, right? So that is just how it is. There's nothing there in JAMB. One of the problems I used to have with my students is that a lot of them, one of the problems I have with my students is that a lot of them have fear in themselves. You see someone that is good, but the moment you start talking up like someone that is good in chemistry, someone that you are teaching, but when you start making, because gradually, even in this class, we are going to be having CBT tests. When I give them CBTs, you see them being afraid of common JAMB questions. Not that they are inside the exam hall, but they are afraid, and it's normal. understand that the fear is also there, like the fear of failure. You know that when you fail JAMB, it determines whether you are going to enter university, and even whether you enter university, it determines whether you're going to study your dream course. So a lot of students are like they're afraid of JAMB and stuff like that, especially chemistry, biology, physics. Especially there are people that are not good in physics and other stuff. But I want to let you know that there's no need to be afraid. Yes, and just believe in yourself. Do your own best. Yes, do your own best. Study. You understand? Study to show yourself approved. Study, attend classes like me, the way I'm doing now. Make good use of this class. I'm not charging money for this online class. So make good use of this class. Then if you want to also learn further, if you want to learn deep, sign up for my class. Chat me up on WhatsApp. Just sign up for my class, just 5,000 naira. Now in my class, you do chemistry, biology, physics, and English language. So you're not just only for English, physics, chemistry, and biology. You're going to do the rest. And you also have access to study materials. And you have direct access to me. Chat me up anytime. I'm always active. Chat me up 1 a.m. I will reply. Chat me up 2 a.m. I will reply. So that is the time me and my students will study most of the time. By around that midnight and stuff like that. So let's answer the next question. The next question here says, which particles are found in the nucleus? So just like what I did, which particles are found in the nucleus? We have A, protons and electrons. Please answer this. So I want answer in the comment section. So people should be very active to answer this question. Okay, how many hours a day do you advise us to read? All right, I'm going to answer that question. Just give me 1 minute. Which particles are found in the nucleus? We have A, protons and electrons. We have B, neutrons and electrons. We have C. So we have A. Which particles is found in the nucleus? C is the nucleus. So which particle is found in the nucleus? We have A, protons and electrons. We have B, neutrons and electrons. We have C, protons and neutrons. And we have D, electrons only. All right, so what is your answer? Which particle is found in the nucleus? Remember when I talked about the nucleus, when I discussed the concept of the subatomic particles, the electron, the proton, and the neutron? I discussed also about the nucleus. So what is the answer? I want to get answer. Let me drop your answer. Which particle is found in the nucleus? Correct. The protons and the neutrons. The protons and the neutrons are found in the nucleus. So Divine, you are correct. All right, so let's move on. I want to answer your question now. So Divine asked me that how many hours a day do you advise someone to study? So I believe this question is because Divine wants to write JAMB. So that's why Divine is asking me now, how many hours do I advise? Now, when it comes to studying, what you have to know is you have to understand yourself. Are you a morning reader? There are some people that wake up by 1 a.m. to study. Are you a morning reader? Are you an afternoon reader or an evening reader? Now, when you know this, if you are an evening reader, you like reading in the evening, ask yourself, what do I used to do during morning and afternoon? Do you understand? What do I used to do during the morning and afternoon? And why is it that I love reading in the evening? These are the basic questions you have to ask yourself. Now, why I'm saying this is because a lot of people love reading in the evening. But during the morning and the afternoon, maybe their parents own shops. Maybe they go to help their parents in the shop, or yes, like shop. They help their parents in the farm. For those people that like farmers, me, I used to go to farm just because I am in school now, so I don't go to farm. But imagine I'm in the village with my parents now. Morning and afternoon, I'll be in the farm. I'll come back around 4 p.m. Now, note, when you come back by that 4 p.m., you'll be tired and you will need to eat and you need to rest and shower and stuff like that. Right? Now, what is there is that for you, now the thing depends on how long you have started studying actually. And I don't know whether you have the JAMB syllabus and stuff like that. It depends on how long you have started studying. For me, I advise you to study 3 hours. Yes. But I'm not saying these 3 hours is universal though. But if you know you can study more than 3 hours, if you don't have anything to do, if you are like a soldier, your parents are training you to just score high in JAMB, you don't have anything, you don't have any distraction, you can just be studying, you can study but 3 hours. And when you are studying for 3 hours, don't just carry your textbook. Let's say you want to read biology now, don't just carry biology and read a particular topic and close it and say you are done. You understand? Try to do past questions and what is known as active recall. So active recall is when you finish reading, you close the textbook and say you can quiz yourself, ask yourself questions based on what you just finished reading. Now for JAMB also, try to get past questions and answer. You can get past questions from me. Now the kind of past questions I have is the past question that give you topic by topic. You get the questions based on topic by topic. So like right now that we are doing atomic structure, that is why we have questions only based on atomic structure. The day we are going to do electrolysis, you're only going to see me answering questions based on electrolysis. The day you're going to see me doing Gauss law, you're only going to see me doing questions based on Gauss laws. The day you see me doing nutrition in biology, I am only going to answer questions based on nutrition in biology. So you can also use past questions like that, and you can get it from me. Chat me up on WhatsApp. Yes, for just 1,000 now, you can get any of the subjects past question that you want. For just 1,000 now, you get it. And I tell you the truth, use it. You understand? So you can say, okay, you study directly for 1 hour, but 1 hour is 3 hours is small though. But I'm just trying to be realistic. But for someone like me, I will not study for 3 hours. I will study for more than 3 hours. But I'm just trying to be realistic. Let it not be like I'm trying to exaggerate something. Because individual differences are there, right? So when you study for 1 hour straight, try to use the past questions. I made a video. Check out my video. I made a video on how you can use past questions, right? So just check out that video, how to use past questions. I think I made 2 different videos where I was trying to explain in-depthly on how you can use past questions. So the mind, how many hours you can study in a day is depending on yourself, depending on your strength. If you want us to talk further, based on you want me to coach you and help you, then chat me up on WhatsApp. You understand? Let's have a personal interaction. That is what I do. Have a personal interaction so that everything I'll be saying is going to be tailored based on your individual experience and reality, right? So that is just how it is. So let's answer the next question here. The next question says isotopes. Yes, I didn't talk about the concept of isotope because I was trying to, like I said, when we answer the questions, we are going to see isotopes or other terms. There are also other terms there. Now we say isotopes differs in their number of A, protons, B, electrons, C, neutrons, and D, charges. All right, so that is the question. Isotopes differs in number of A, protons, B, electrons, C, neutrons, and D, charges. Now, the first question you're supposed to ask yourself is, what is isotope? What is an isotope? An isotope is a phenomenon or the occurrences of what elements is a what phenomenon or the occurrences of elements having the same atomic number but different mass number. This is the atomic number. This is chlorine. This is the atomic number because chlorine is one of the elements. Oh, there's light. Bless God. I'm coming. Let me change let me remove my battery. There's lights now. Hey. It's not very good. Differs. Okay, like I was talking about chlorine now. So chlorine is one of the elements that exhibits the concept of what? Isotopy. Right? So this is chlorine with atomic number of what? 17. Now it's as in the mass number there is 37 and here's what? 35. This phenomenon is known as what? Isotopy. Now isotopes differs in their number. This is protons. The atomic number is the number of what? Protons. Now the mass number is as a result of the differences in the number of their neutrons. So mass number, so say mass number, right? The mass number is as a result in the differences of their neutrons, and the protons is also known as the atomic number. So we have isotopes differ in their number of A, protons, which is wrong. Their protons is the same. B, electrons, no. C, neutrons, and D, charges. The correct answer there is what? Neutrons. Right? So that is the concept of what? Isotopy. In the course of this class, I'm going to show you how you can solve isotopy. It's one of the major questions that we always see in JAMB. Right? So we are going to see it as we continue. So let's just solve the next questions. Now the next question here is, what is the electronic configuration of magnesium? What is the electronic configuration? All right. What's the electronic configuration? What is the electronic configuration of what? Magnesium. All right, of magnesium. Magnesium is 12. Right? Following the okay, so which of the question do you want? Divine. Which of the question? You mean the concept of the isotope, right? We'll talk about, like I said, the concept of isotopy. I'm going to still talk about it again. You understand? We are still going to talk about it. I say isotopy is based. Yeah, that's isotopy, the one we just finished doing about. I say isotopy differs in their number of what? Neutrons. The isotopy. Yes, it's isotopes. Yeah, that's what I'm talking about. The isotopes is based in the differences in the number of their what? Neutrons. So let me just touch this for Divine. So Divine, be active. Let me just touch this because of you. So I say we have an element known as chlorine. Now chlorine is one of the elements that exhibit what? Isotopy. Isotopy is a phenomenon or an occurrence whereby a particular element have the same atomic number but different mass number. So this is chlorine having atomic number of 17 but having a mass number of 35 and what? 37. What this means is that there is a difference in the number of their what? Neutrons. So differences in the number of neutrons affect what? Mass number. This is atomic number and this is what? Mass number. Do you understand? So the differences in mass number. Yeah, so the differences in neutrons results to what? Mass number, which is results to the concept of what? Isotopy. So don't worry, in the course of our continuation, because I believe there's also questions here that we are going to solve. So that's I'm going to teach you how you can be able to solve isotopic. When you see a question that is based on isotopic, you can know how to what, solve it. What is the electronic configuration of magnesium? Knowing that fully well that magnesium is 12. The atomic number of magnesium is 12. So we have, like I said, the innermost must contain a maximum. The innermost must contain a maximum. So we have SPDF, right? The innermost must, we have KLMN. The K contains 2. L contains 8. KLMN. M contains 18. But because of JAMB, we reduce it to 8. So we have 288, right? So let's see what we have here. Magnesium equals to 12, right? So what we are going to have, we say solution. We say 2, 8. This is 2 plus 8 is 10. And this is what? 2. So this is the electronic configuration of magnesium. As simple as that. No problem. Right? So this is the electronic configuration of what? Magnesium. Please subscribe. For those of us that are just joining the class, please subscribe. And also help me share my class. Please share it to your friends on WhatsApp. Just share it on WhatsApp status. Share it on your WhatsApp status. Share it to your friends. Right. So let's see another question here. All right, let me see. All right, I'm trying to get question here. Divine. So I've seen a question here also that's relating to isotope. It says, why are isotopes chemically similar? Why are isotopes chemically what? Similar. Now, what makes an element to be chemically similar is based on atomic number. What makes an element to be chemically similar is based on their what? Atomic what? Number. Is based on the atomic what? Number. So an element like chlorine, for example, having an atomic number of 17, having different mass number. The element is still having the same chemical properties because of their what? Atomic what? Number. So what makes element to be what? Similar, right? Is because, or chemically similar, is because on their what? Atomic number. This is because they have what? The same chemical what? Property. This is chlorine, this is chlorine. Despite the fact that there's a difference in their number of what? Neutrons, right? So that is just how it is. Let's see another question here. Most of the questions here are like repetition because I've already taught you how to solve. So if I've taught you how to solve, most of the questions here, I think, is something that you can get these past questions from me on WhatsApp for 1,000 naira. Can get these past questions from me on WhatsApp. Chemistry, physics, biology, and English language. You can get it from me for just one of it is 1,000 or so. English language is 1,000. Chemistry is 1,000. Electronic configuration of aluminium. So this one is not, aluminium is 13. So we have 283. So this one is not something. All right. I'm trying to look for a question. Define what's atomic number. This one is atomic number. Atomic number is the number of protons. Now take notes. Let me just say this. Because we just have some time left. 1 hour. This class is a 1 hour class. This is our introductory class. So tomorrow we go. I think tomorrow is biology. We have timetable for this class. We have a timetable we are following. So I think tomorrow is biology. So atomic number is the number of protons. Right? Atomic number is the number of protons. Mass number is the number of protons plus neutrons. Are we together? Mass number is the number of protons plus neutrons, while atomic number equals to number of protons. So let me see. I'm trying to see the question. Most of the questions here, like I said, JAMB is not hard to. It is mindset. It's a mindset. You understand? JAMB is not hard. When I'm going to be doing my live, I'm going to be hosting a live CBT class. You are going to be seeing me live as I'm answering JAMB questions without cheating, without any aids, without any help. I'm going to do it live. That's it. And you're going to see my score. I'm doing it to show people that it is just JAMB is just require technicality, the ability for you to think fast and to think fast under pressure. And that is what JAMB is all about. The ability for you to think fast and accurate under what pressure. Let's solve two more questions, and we call it a day. Now we have this particular question. It says, what is the valence electron? What is the number? What is the number of valence electrons? Number of valence electrons in 2A3. Valence electrons in 2H3. Now we say solution. Right? We say solution. We are going now to the orbital. Okay, when are you starting tomorrow? Our classes is by 11:35. I'm supposed to set everything. Today, why I delay what I was just trying to, I came back from somewhere, so I was just trying to set up. 11:35, just be active and we start our class. 11:35 daily, Monday, from today to the end of, apart from Sundays and probably on Saturdays, but from Monday to Friday, we are going to be having our online classes. I'm just doing this online class is for free. You are free to attend my online class. I don't charge money for it. I'm just doing, this is an exposition. I call it exposition. I want to expose JAMB. Position. I want to expose JAMB. I have students I've trained students in JAMB classes. I have students who scored 294. I think last year, that is 2025, my highest student in my tutorial, that is my all-time. I'm just going that this year, I'm going to break that barrier. My highest, like, I don't call it a barrier, but my highest student was 331. Yes, I had 331, I had 316, I had 285, then I think I have 260, 250, and the rest. But this particular person, 331 was the highest. And this year, I'm planning to add, even though it's like maybe like 15 mark, I'm going to add extra 15 mark because I must get someone scoring up to 350 in my tutorial. You understand? So follow up this class and you are really going to enjoy it. I have been in the business of taking JAMB students over time, so I know how JAMB sets their questions, and I know how to predict a possible question that is going to come out. So when you are following up this class, and if, like I say, if you want to go further with me, chat me up on WhatsApp, sign up for my class, buy my past questions, and we are there. So number of valence electrons in 2A3. Now, to get this, let's go to our atomic orbitals. And this is our atomic orbital. This is orbitals, right? Now the question is, what is an atomic orbital? An atomic orbital is a region of space where there is up to a 98% probability of finding an electron. 98% probability of finding an electron is known as what? Atomic what? Orbital. So when you see an atomic orbital, there's a 98% probability of finding what? An electron. So we have this electron here, this electronic configuration, 283. So let's see how we can fill it in. Like I said, the innermost must contain what? 2. We have yes, and we have 1, 2, 3. So this is 2, 8, 3. That is 10, 2 plus 8, 10, 10 plus 3, 13. 2, 8, 3. Now the question there is, what is the valence of electron? Remember I talked about valence electron. I said valence electron is the number of electrons found in the outermost shell. The number of electrons found in the outermost shell. Now this is the outermost what? Shell. Right? So how many electrons are found here in this? This is shell number 1. This is shell number 1. This is shell number 1. That is 1, 2, 3. Shell number 1 contains 2. Shell number 3, shell number 1 contains 2, sorry. Shell number 2 contains 8, and shell number 3 contains 3. Now, shell number 3 is the most what? Outermost what? Shell. And it contains how many electrons? It contains just 3 electrons. So the valence electron here is what? 3. Now the question again is, which group? This one want to ask you, which group is this particular what? Element? This element is found, so we say valence electron is 3. The group, this is group 3. The period is 3. The group is 3, the period is what? 3. Now the group, right? The group is the number of what? The valence what? Electron. The valence electrons give us the what? The group. Now the period here is not what? The number of what? Shells. So how many shells do we have? 1, 2, 3. That is not a period. Are it being the shell increased to 4? So you can say the period now is what? 4. Do you understand? So that is just how what it is, right? So this is the basic understanding of what you are supposed to know when we talk about the concept of what? Atomic what? Structure. I've given you why we say an atom. According to John Dalton's, atom is an indivisible particle of an element. Scientists say no, you cannot say an atom is an indivisible particle of an element. An atom is divisible because this atom is made of subatomic particles, which is a what? The first scientist came out, he said his name is what? J.J. Thomson. He said, I was in my lab and I found out that there is what? A negative what? Ray. A negative what? Ray. Right? That was able to pull. A particular what? Weight. Right? He said, and I call this ray, I'm calling it what? Electrons. And these electrons are what? Negatively what? Charged. And then the man came out, he said, my name is Ernest Rutherford, and I want to say that there's a subatomic particle which is known as what? The proton, and the proton is positively charged. And another scientist came out and say, we have another subatomic particle which is known as a neutral. Now the neutral is neutral, right? There's no charge. And it was discovered by a man known as what? James Chadwick. Now, another man again came to discover the charge of what? An electron. Although I didn't talk about him, but his name is known as what? Aru Millikan. His name is Robert Millikan. He discovered the charge of what? An electron during his oil droplet experiment. So this is what he just what there, and this is the basic of what I want you to what know. You can be part of my intensive WhatsApp class on WhatsApp, like intensive WhatsApp classes from Monday to Friday. That's when we have our class, 7 p.m. to 10 p.m. So you can also learn from YouTube as you are doing now, and you can also be part of this class on WhatsApp. I promise you, when you take your JAMB serious, you are going to smash JAMB UTME. You can get these past questions from me, like I've said, and can also decide to chat me up on WhatsApp. You can be if you want to be my friend, if you want to get to know more about how you can be able to smash JAMB, maybe a little bit, 1 or 2 counseling, you can decide to chat me up on WhatsApp. And if you're just coming across my channel for the very first time, my name is Basi Ejogba. If you're just coming across my channel for the very first time, my name is Basi Ejogba, and I'm a medical student at the University of Calabar. And in my channel, I help students level up the academic game. Right, so it's chatting up on WhatsApp, and until I see you tomorrow, always remember that you're wonderful, always remember that you're unique, and always remember that you're a pace setter. I really love you. Thank you. All right, so thank you so much for joining my live stream section. I will see you all tomorrow, same time, same venue, and tomorrow is biology. Don't forget to share my class. Don't forget to share my class with your friends. All right, Divine. Bye.